All right, let's get going. Thanks everyone for coming up today for our OpenTSDB and Bigtable session. I was really excited and actually surprised to know that there's a separate track for time series. When I submitted the talk, I didn't know about that. I thought it's just, yeah, great, we'll talk about OpenTSDB and Bigtable. And it looks like it's a really hot topic at Percona Live, which is really amazing. And so it was really great to hear about all other time series backends. And today we'll talk about something slightly different, which I think we haven't seen in other presentations. And specifically, we'll be talking about integrating OpenTSDB with Google Cloud Bigtable. My name is Danil Zburivsky. I'm a leader of big data practice at Pythian. And with me, my co-presenter, Christos Soulios, who is our big data architect. So I will do a quick intro about time series and about why we even started doing this project. And Christos then will take over and talk more about the implementation side of things and how we actually did it. Really quick about Pythian. We are a consulting and managed services company. We provide support for relational databases like MySQL, Oracle, SQL Server, NoSQL databases like Cassandra and Mongo. And my team specifically is responsible for architecting and building big data platforms, whether on-prem with Hadoop or in the cloud with things like Bigtable or BigQuery or Redshift. That's pretty much what my team is doing. So time series, like if you've been attending previous sessions of this track, you probably heard about 10 times about what time series is and why it's important. But a quick refresher, it's essentially like a through tuple of a time, a metric, and a value assigned to it. And it's a really simple concept, but it's really powerful, right? Because it describes so many processes in the real world, and you can use it anywhere from monitoring applications to collect the data about how your system behaves, to industrial equipment and sensors that monitor pressure and temperature, to even collecting web traffic and events from your applications and things like that. But again, the concept is very simple, but it's really powerful, very descriptive, and that's why I think it's really important to have databases and storages that can efficiently deal with this data. Why storing time series is a challenge? Why don't we just have a MySQL database and store everything in one database and just forget about it? Again, the challenges are pretty common. I'm pretty sure you guys heard about this before, but the main problem is that the data in time series arrives in one pattern and being consumed in a completely different pattern. And the volumes of time series can be explosive because if you're thinking about monitoring applications or sensor data, it's easy to see how adding more nodes to your infrastructure or adding more sensors on the equipment can just be result in explosive growth of the volume of the data. But as for the access pattern, as you can see, you can imagine that if we have some measurements, M1, M2, and M3, we receive the data pretty much sequentially in time. So for each time point, we have one data point for the measurement, right? So data kind of arrives in these virtual columns for each measurement. But when it comes to consuming the data, in most cases, you want to consume it in a completely opposite way. Like you want to consume it in this kind of raw format where you want to look at one particular metric and read a long series of measurements. So, and that's essentially that's the challenge. Indexes in relational databases, you can index one way or another way, but then you either slowing down the writes or you slowing down the reads. So there's just no ideal solution for that. And there are some tricks and things that people do to fix this. And if you attended Baron Schwartz's talk from with Cortex yesterday, they're doing this in MySQL. They're storing time series in MySQL, but they are really using it as a NoSQL store, essentially. They're not using any MySQL specific features. That's the challenge that time series databases are trying to address. There are better alternatives, right? So instead of trying to feed those time series into relational databases, we invented multiple alternative specialized stores, and you've seen at this track for time series there's more probably every year being added to that list. And the idea is that we will use the data model and storage that's optimized for time series. So we'll invent kind of our own structures that will be more efficient just for that use case. And the trade-off is that we'll probably have to use a separate query language for accessing that data because we are kind of building our own layer on top of the storage. And today we'll talk about OpenTSDB, which is probably the most established time series database. It's been around for a long time. It's obviously open source. It uses HBase as the data store, and it has a data model that's optimized for time series. And we're actually very lucky to have Chris Larsen here, one of the committers at OpenTSDB. Later today, he'll be talking more in depth about the data structures. So if you're interested, definitely attend that talk as well. Essentially, what OpenTSDB does, it provides us the data model that's optimized for time series and an API on top of that allows us to work with the data easily. So on a high level, OpenTSDB architecture looks something like that. So you have a number of servers, if it's a monitoring use case, but those servers could be, again, like sensors and stuff like that. You have TSD instances, which are Java kind of agents sitting in between servers and HBase. And what's happening is those TSD instances actually do the translation of the operations that you do with time series, like insert a metric, insert a new measurement, get an aggregation, get a value for a given point. And at the storage layer, OpenTSDB relies on HBase, which is a scalable NoSQL storage built on Hadoop. And really, in this case, what's happening is TSD is giving you this kind of translation language, right? You don't work directly with the data in HBase because the model is so highly optimized. For time series, it's very hard to work with the data manually. It has very compact storage, and you need this kind of layer to translate your requests into the request to the storage. And TSD has some built-in web UI, which is pretty scary, but it supports. It supports all the modern kind of graphing tools, so you can plug them in and actually display the data in TSD. And you can also plug into the RPC to do any kind of scripting for alerts and stuff like that. But this is not an in-depth overview, just so you understand. The service sends the metrics to TSD. TSD translates them to the HBase operations. And if you want to query, you also query through TSD. You don't go to the HBase directly. But the challenge that we've seen, and I think many people have seen, is like, okay, I want to build the metrics collection solution, and OpenTSDB is great, but HBase is just too much sometimes. Like, HBase requires a full Hadoop setup, 3 zookeeper nodes, 2 name nodes, 3 data nodes minimum, and 2 master nodes, 2 HBase master nodes, 2 HBase region nodes, 3 actually, region nodes. So you need a full-fledged cluster up and running just to get your data collected and monitored. So if you're building a monitoring solution for your in-house infrastructure, you're actually building more infrastructure just to monitor that infrastructure. It's a very challenging task. And HBase is a great NoSQL store, but it's rough around the edges sometimes. And tuning HBase and dealing with some of the challenges there is not for faint of heart. There's a lot of stuff going on, and there's a lot of components that can break. So HBase is scary. It's a lot of stuff inside, and everything there can break. So you have to be ready that. It's becoming better and better, but still it's a lot of management overhead. So if you don't have Hadoop already, and you don't have a team of Hadoop admins and with HBase skills, it's probably a blocker for you to deploy OpenTSDB on HBase because you will spend more time just managing the cluster than you actually spending time doing what you need to do. But all we wanted was actually a time series database, right? So we wanted to store this simple data structure in a predictable and scalable way, right? We didn't want to roll our own Hadoop clusters. So luckily, a better way exists, and we will be, in the second section of this presentation, we'll be talking about Google Cloud Bigtable and how OpenTSDB can integrate with that, and why would you want to do that. And here I will hand off to Christos.
Hello, can you hear me? Yeah, so hello everyone. Yeah, what I would also like to add is like, if it is a tough job to set up an HBase, a Hadoop cluster on-premise, then setting it up in the cloud is like 10 times more, because it is more expensive, it is harder to get, like configured disks and IOs and everything. So let's see if we can do something else, if we can have another approach to this problem. And maybe we can check the Google Bigtable. So I won't go into too much detail about Google Bigtable. It is like an HBase alternative. In fact, it has been around for quite more, like 10 years as an internal project in Google. It is like a massively scalable NoSQL database. It supports high throughputs, low latency, and high concurrency. So yeah, it used to be like most Google products work on that. And lately, as of like a year or so, it has been released as a Google Cloud service. So when Google Cloud Bigtable was released, we were approached by Google and saying, like, here's what we're going to release. And if you would like to have some business use cases that work on Bigtable, something you run on HBase, because we are originally a Hadoop HBase team, so can you change that? And like OpenTSDB was a very good candidate for what we've mentioned before. So Google has done something really smart so that they can attract HBase users. Since HBase and Bigtable are kind of similar in architecture and approach and data structure and everything, they created a library that is API compatible with HBase. What does this mean? Like if I have an HBase client application and I want to change it and migrate to Google Bigtable, all I need to do is like drop the new jars, like the Bigtable HBase jar. No code change is required, just configuration and replacing the library. So we said, all right, that would be an easy task. Let's take OpenTSDB, replace the libraries, and then test it and see how we go. Unfortunately, it was not that easy. It was not that simple. And that is because OpenTSDB does not use the standard HBase client. In fact, what the OpenTSDB maintainers have done is they have rewritten the whole HBase client stack, and they've replaced that with an AsyncHBase library. So what's AsyncHBase? It is an open source HBase client library. It is multi-threaded, while back a few years ago, HTable was not multi-threaded. Latest release is, and it's fully asynchronous, non-blocking, implementing the low-level HBase RPCs that change every few months. So this is a tough job. And like, I don't know, for people that have been writing software, like asynchronous programming is like a hot thing nowadays. And that is like, so far, when we wanted to have I/O, call network I/O, disk I/O, or anything, when we were actually calling a function, it used to block. And then doing things in the background. We were waiting, like the thread was blocked and probably was removed from the scheduler. And then when the result was ready, we were going to wake up the thread and then give the results and go on. That cannot scale. Asynchronous, what it does instead is like when we invoke a call, then we return a future. This is just a handle. That does not mean that the result is there. It means like we will be able to access the results through this handle. And then later, when we've done some work, we can either call get and then block, or even we can add some listeners. So we can chain more methods that will work asynchronously, and then more methods, and then essentially what we can build is like a chain of asynchronous methods. And this is good. I mean, that's really good. Why? First, because we have an efficient thread usage. So like so far, we'd have many threads that would block on I/O and then remove from the CPU, and then entering new threads that would block, and so on. Now we have less threads that perform more work. They don't block, they don't wait, they don't need to be rescheduled. So for a start, we use less threads, so it's less memory. Second, it is CPU scheduler friendly, so we have cache affinity. We don't have to move our threads here and there. And finally, we have extremely high concurrency with lower resources. So that is a graph from the AsyncHBase library, and it shows the sequential writes for the HTable API and the AsyncHBase, depending on the writing threads. So here you can see like how latency increases with HTable, and it stays the same with AsyncHBase, and also the page faults. That are very, very important KPI. So we said, all right, yes, AsyncHBase is like very good implementation. We won't be able to be as fast, at least in the beginning. Let's get that started, then probably we can improve the performance later. However, when we started looking at the documentation of AsyncHBase, it says like it's totally different. It has its own API. Okay, so just switching to HBase is not a simple thing. It's not like drag and drop the jar. We need to write code. And essentially, that's what we had to do. So what we did is we developed the AsyncBigtable library. And what we did was like what Google did for HBase, that's what we did for AsyncHBase. So we wrote a API-compatible library that can replace AsyncHBase and then use the standard HBase client or Bigtable libraries. So yeah, that would be the plan. And let's see what were the challenges there. So for a beginning, OpenTSDB is really opinionating when it comes to jar dependencies. And I don't know if anyone of you has worked with Java, but there's that thing like jar hell. So you add some libraries, some jars, and they have some transitive dependencies that need more, and then it did more. And then in the end, you wanted 4 libraries, and you end up with 50 jars that you don't know what they do. And sometimes you have version conflicts and everything, so you don't want to be there. What the OpenTSDB maintainers did is like they decided to keep it simple. So all libraries will be there explicitly and keep it as slow as possible. Of course, yeah. What we wanted to do is add all the libraries, but at that moment we did not want to like touch the dependency system of OpenTSDB that much. So what we did at that time is like we created an Uber jar, a super jar, which is like a fat zip file containing all the libraries in there. And instead of giving 20 libraries, we gave a big library, 55 megabyte, like takes a while to upload, but it seemed to work after a while. Second thing is like AsyncBigtable is not async, okay? And that is because we use the standard HBase API, which is a blocking API. So what we do is like we call at Bigtable and then wait and blocking there. And that's not a good thing. First, because the rest of the OpenTSDB infrastructure just waits to return immediately. And then we ended up with many threading issues, like increasing the workers did not work. Sometimes we would run out of threads and so on. So what we did instead is like we used the buffered mutator and a thread pool. So we kind of emulated the async behavior. That meant like what we did is instead of writing one by one all the inserts or doing the gets, no, that's for the inserts. Instead of doing one by one the inserts, we were actually buffering them. And then we had a separate thread that would pull from that buffer. So yeah, when the buffer gets full in very high concurrency, essentially threads block again. But for now, this can take us far. So here is like a short benchmark we have done. It's not something extremely reliable, and that is because AsyncHBase works on a single node HBase on Google Cloud. And you know that like if you have a single node, you don't have all those replication issues, you don't have consistency issues, you don't have nothing like that. And we have a local storage, not HDFS, which is another thing. So we made it like a simple run, made it reach up to like 39,000 events per second. Our first version of the library, which was 0.2, could reach about 13,000 events per second. And last week, we released the 0.3 that actually uses latest Bigtable client API, and it has some performance improvements. So I think we're getting good in that. So AsyncBigtable library, this has been accepted by the OpenTSDB project, and it has been merged upstream. We do our best to help there. I mean, provide more code, provide feedback and everything. And if you want to check, here's the documentation, how you can enable that, and here's the code on GitHub. What we intend to do first is like There's another Bigtable API that is not HBase replacement. It is native. And this supports asynchronous calls. So we intend to actually re-implement the AsyncBigtable using the native Bigtable API so that it is essentially asynchronous. And then this will improve performance. We have many more things to check for improving performance, such as like memory management, thread management, buffers, and everything. And finally, we need to add more tests. Like for now, we haven't done much in this thing. So yeah, I think that was all. We'll take some questions.
What's the biggest Bigtable in production that you run for benchmark?
We've been to like 3 node instances and 5 node instances. We haven't been to more than that.
Honestly, we are on a path trying to get more support of the using your guys' work. And we have done some scalability issue because otherwise we don't know when. We should just started last week, so
Yes.
we really want to.
Most of the times in our test, that was like due to the blocking behavior of the table. So you had the buffers full, okay, and you can increase it, but you can't get that far. And then you have many threads writing. So when the buffer essentially gets full, then everything blocks. And like another bad thing here is like the write path and the read path actually use the same threads. So you may have like real hard traffic on the write path, and then you cannot even view the graphs. I think this is going to be resolved like if we do it asynchronous and solve it once in a while.
You guys can use this as a backend of your own service or your own SaaS service, or how do you plan to use it?
Well, for us, that was not like something we had like an internal use. It was a good case on which we could work using the Bigtable client. And yeah, it has proved to be like a real need out. Like there's a lot of people that have asked us like, yeah, how we can do that work and those things.
Yeah, Google Cloud Bigtable.
You mean that one? Or
Yeah.
yes.
Can you tell me the throughput you have like through AsyncBigtable?
Well, that's AsyncHBase, and that is AsyncBigtable 0.2, which is like what is currently running on 2.3 release. And this is AsyncBigtable 0.3, which was released last week, and it's going to be like pushed in the future.
Can you tell me what are you running in the back of that? What kind of Bigtable infrastructure?
That one is like 3 node setup. It's not so. Yes, and also here I would like to say that Bigtable is like, it doesn't feel any hard. I mean, like we write as much as possible, but we cannot like take all Bigtable load. Instead, what we have tested so far is another setup where we have like on the same machine 2 different TSDs and then send messages. And this actually shows that we have twice the writes. So for this setup, yeah, 3 node Bigtable was like nothing.
Yeah, it doesn't show the performance of Bigtable.
Yeah, that's like HBase. Right now, HBase client library is blocking. It does not support like non-blocking asynchronous I/O. HBase 2.0 supports that, but I don't know when it's going to be out. Still, it's a snapshot. And this is why we need to figure out if like HBase asynchronous API is going to be out soon so that we can work on that, or we can just like bypass this API and work directly with like Google libraries for Bigtable that supports true asynchronous behavior. Like libraries there, you can download, but yeah, Chris, you plan to do that like in the following month, few weeks?
Yeah, a couple weeks.
Yeah.
There's a pull request on GitHub.
Yeah, that's already.
Merge every build to
So, but yes, if you want, you can just download it, replace the current snapshot library with this, and then it will work. And also there are a few changes on the documentation because from like a year ago, they have changed the connection parameters for Bigtable. I'm going to file a pull request for the TSDB documentation too. Is anyone using like OpenTSDB in production with HBase right now? So yeah. Any other questions? Thank you very much there. Thank you.